In this video, we are going to discuss the derivatives of log functions. And this will be the last of our major types of functions that we take the derivative of. And suppose that we want to differentiate the function y equals natural log of x. Now, what we know about the relationship between log functions and exponential functions, we can rewrite that. If we have the original function y equals the natural log of x, that's in log form. We know about writing it in exponential form. We move the base to the other side, and we have x equals e to the y power. Now, we don't know how to differentiate y equals natural log of x, but we can differentiate e to the y as long as we use implicit differentiation. Remember from Algebra 2 pre-calc, these equations are the same. They're just in different forms. So I'm going to take the derivative of x equals e to the y. And so here would be 1 equals e to the y times y prime. Tack on the y prime because we're differentiating with respect to x. Divide both sides by e to the y. But now we don't want to have y in there, but we do know back here that e to the y is x, so we're going to make it y prime equals 1 and replace that e over y. We're going to replace it with x. So the derivative of the natural log of x equals 1 over x. Now we could do a similar proof for other bases, but you can look that up for yourself if you're interested. If we have log base a of x, the derivative of that is still 1 over x times the natural log of a, natural log of the base. Those are the basic derivatives of log functions. All right, well, let's use that and calculate some derivatives. So it says differentiate f of x equals x natural log of x. Well, we can see there are two functions multiplied together. We need the product rule. First times derivative of the second plus the second times derivative of the first. So it would be x times the derivative of the natural log of x plus the natural log of x times the derivative of x. Well, this would be x times 1 over x, which of course is going to cancel, we're just left with 1, plus the natural log of x times 1. So the derivative of x natural log of x is 1 plus natural log of x. Let's look at another example. This time we need the quotient rule. Log of x over x squared minus 3x. So we use the quotient rule, the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all over the denominator squared. So that would be the denominator is x squared minus 3x times the derivative of the log of x minus the log of x times the derivative of x squared minus 3x all over x squared minus 3x squared. Good. Alright, so let's simplify and get our derivatives in here. We got x squared minus 3x, and the derivative of the log of x is 1 over x times the natural log of 10, which of course is the base, common log, minus the log of x times the derivative of x squared minus 3x, which is 2x minus 3, all over x squared minus the 3x quantity squared. Now, do any simplifying that we can do. There's not a lot here. We can pull out an x out of here. This becomes x, and then x minus 3, and this x and this x here and this x here cancel. So what I'm left with is x minus 3 times the natural divided by the natural log of 10 minus the log of x, 2x minus 3, all over x squared minus 3x squared. Now that's of course not simplified, because they would not leave the second fraction in the top there, although it's not horrible, especially these days, but this is the derivative in an unsimplified form. Right. Let's do example 3. So same thing, you use the quotient rule again, so it'd be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So that would become e to the x, and the derivative of that 1 over x times the natural log of 4 minus the derivative of that, of course, is e to the x, its own derivative, over e to the x squared. Now, since this has an e to the x, this term has an e to the x, and this has e to the x squared, we actually can cancel this, this, and that. And we'd have 1 over x times the natural log of 4 minus the log base 4 of x all over e to the x. And to put that into one fraction, if you want to see how to simplify this one, because this is, of course, again, this is the derivative in unsimplified form. To simplify it, make the denominator have a common, this have a common denominator. So it'd be 1 over x natural log of 4 minus x natural log of 4 log base 4 of x over x natural log of 4 all over e to the x. And then we can combine the two denominators and combine the two fractions into one. We would have 1 minus x natural log of 4 log base 4 of x over e to the x times the x times the natural log of 4. That would be in simplified form, right there, and the best that we could do at that point. Alright, so let's look at the chain rule with log functions. Okay, and let's take this function here and differentiate the natural log of x squared minus 3x plus 5. So of course we have to use the chain rule, so that would be the derivative of the outside times the derivative of the inside. The derivative of the outside function is 1 over, and we keep the inside function there, x squared minus 3x plus 5, times the derivative of the inside, which the derivative of x squared minus 3x plus 5 is 2x minus 3, and then combine the fractions 2x minus 3 over x squared minus 3x plus 5. That's the derivative of the natural log of x squared minus 3x plus 5. Okay? So that hints at a way to easily differentiate chain rule problems when it involves logs. Okay? If we have the natural log, the derivative, try to take the derivative of the natural log of g of x, some function g of x, involves the chain rule. You can see what we have here. On the top, we put the derivative of the bottom function. And that's the shortcut. It's g prime of x over g of x. And if you have any other base, so log base a of g of x it's going to be the same. It's going to be g prime of x over g of x times the natural log of the base, just as our original function was. Okay. So if we take that into account and we do another example here, we have the log base 5 of 4 minus sine of x. It's a chain rule, so f prime is going to equal, take the derivative of the inside, which should be 0, and the derivative of negative sine is negative cosine of x, divided by the function 4 minus sine of x, and then times the natural log of the base, which is 5. There is our derivative. Okay. And let's look at